Okay, so we're going to talk about a rumen dump. If you were here, we go out to the cow and reintroduce you to 595. So we remember how big that rumen is, how wet it is, how hot it is, how much it stinks, all that stuff. But we wanted to look at the rumen in a more quantitative sense. So in the past, we've measured this out. We go through, we fill that garbage can, we almost fill it. So we're looking at about 32 gallons of material. We got that stuff on a scale, we slid that over. We got 170 pounds of wet weight. There was another class that was measuring her earlier in lactation, was 210 pounds of wet weight. So there's a range depending on when her last meal was, what stage in lactation. So the rumen contents vary. We're going to go with this 170 pounds of wet weight. If we go through and we measure that out and things get pretty stinky when we put that in the dehydrator, we're looking at 22% dry matter and 78% water. Her rumen's a little bit drier than most. Usually we're 10 to 15%. I've never really, for whatever reason, scooped water out of the bottom. Normally when we do a complete rumen evacuation, we have to take a small cup and we scoop out the liquid at the end. She's never been like that. You can pretty much do it all with your hands. So she's probably a little bit drier than your average rumen, so that's her personal set point for whatever reason. That 22% dry matter works out to 37.4 pounds of dry matter in the rumen. And that's going to be feed, that's going to be microbes, and that's going to be whatever solids are in the rumen liquid, the liquor, the milieu there. 78% water's going to come from saliva that's you're pulling out. Whatever she drinks, whatever's inside the feed, and whatever's inside the microbes. So you can't really say that it's just a liquid moving around. You've got stuff inside the feed, you got microbes that got there, but when you're drying things down, water comes from all four of those sources. So 22% dry matter, 78% water, 133 pounds of water in that rumen. Multiply the 55 by the percentage here, we get the pounds of each of these fractions that we're eating in a day. So 10.2 pounds of crude protein, 16 pounds of NDF, and 15.5 pounds of starch. So that's what goes into her rumen every day if we're thinking steady state. If we think about the ruminal contents, we took a subsample and we sent it off for analysis. Pretty basic analysis: crude protein, NDF, starch. They also gave us a soluble crude protein. So if we looked at what was there, we have 15% crude protein, soluble protein, 1.5% of the dry matter, NDF, 59% of the dry matter, and starch, 4.8%. We take the 37.4, multiply it by the appropriate percentages. We have, at the time of the dump, almost 6 pounds of crude protein, 0.6 or a half pound of soluble protein, so 5 pounds of true and bound protein, and then about a fraction of a pound there is your soluble protein, crude protein. You got 22 pounds of NDF in the rumen and 1.8 pounds of starch. Now, if you think about this, okay, this is lower than what was eaten. So the microbes are changing things. They're tearing things apart, putting things back together. The protein is being moved down the track in some way, shape, or form. The soluble protein is probably lower than what was being fed. We'd expect the soluble protein 10, 15%. But we know that when that soluble protein goes in the rumen, the microbes snatch it up real quick and make sure that none of it is available so it disappears very quickly. So we have a lower percentage there. The NDF is slow to break down, slow to be destroyed, passed down the lower tract compared to crude protein, compared to starch. So we have an enrichment of the percentage of NDF. The other fractions disappear quicker, they're flushed down the track, the turned into bugs, all those things are altered. Starch disappears very, very quickly, so you go from 28% down to 5% very, very quickly as that starch disappears after a meal. At those ratios in pounds compared to what she eats in a day and what's in the rumen at the time of sampling. And again, this will vary throughout the day depending on when her last meal was and how full things are and how fast the rumen is converting. We know that we have proteins being turned over, being digested, being passed down the tract. We know that NDF is the slowest disappearing fraction, and we have an enrichment of pounds there. She's eating here, and then she's got an additional, looks like 4 or 5 pounds, 7 pounds more that are hanging around in there. So what she ate in a day plus what was left over from the day before. So NDF kind of limits what the cow can eat. We talk about that 1% of body weight that they'll eat to for NDF. The ability to move NDF out of the rumen allows us to get more in. So NDF is kind of a rate limiting step when it comes to the rumen. We talk about turnover times that are about 24 hours. Starch turns over very, very quickly, disappears, is ripped apart by the microbes, so you're going to have very little active starch in any rumen, especially if we start with a low starch diet like we have here. We're not in the 30s. So lots of starch goes in, it disappears very, very quickly, becomes VFAs, becomes microbes, and we don't measure it as starch anymore. So let's think about that quantitatively. So when we're going to calculate something that's called turnover. Turnover is a way of thinking about how fast things disappear from the rumen. So how a rate kind of, what is it, fraction or percent per hour. And we're making these calculations, we're assuming continuous intake, that things are coming in on more or less a steady state basis. That's the way the math has to assume it. And then turnover is the disappearance of the feed from the rumen. There are two ways that it can be disappear. Either can pass down to the lower tract, the omasum, the abomasum, small intestine, so leave the rumen, or it can be fermented and destroyed by the microbes. So we talk about formally, when you're talking about rumen dynamics and what's happening in the rumen, you're talking about passage and digestion. So when we're talking about turnover, we're going to use a formula here where we take the intake, what she ate per day, and what's in the ruminal pool. We'll divide that by 24 hours to get an hourly rate. We'll multiply by 100 to get a percent. So with this formula, we'll get percent per hour that leaves from the rumen. And again, what's leaving the rumen is being digested and passed. That's how we call it formally. It's going down to lower tract and then it's fermented by the bacteria or digested by the bacteria. So what percent per hour leaves given our rumen environment? So we said that the NDF is our rate limiting nutrient. It's the nutrient that determines the fill of the rumen as that NDF leaves, either passing down lower tract or being fermented. You're looking at room for more stuff to come in. And so this number is usually from 3 to 5%. That's what sort of limits things. Again, this is probably not as accurate given the way we sampled everything and stuff. If we have 4%, that's going to work out to about 100% over the 24-hour period. So this is a little bit slower. So she's probably not eating as much as she could. She's probably not limited by NDF intake. Starch, much faster turnover rates. So you're looking at more than a third of the starch in the rumen disappearing every hour. So with this rate here, whatever goes in the rumen is gone in 3 hours. So this is more of a 20-hour, 24-hour. This actually is to get there, we're looking at a 30-hour kind of thing. It was 4%, it'd be 24. This gone in 3 hours. The crude protein is somewhere between the starch and the NDF, that turning over 7.5% per hour. So leaving the rumen.